Welcome, everybody, to an extra edition of The Full Nerd. I am your host, Adam Patrick Murray, and I am joined by one Mark Hochman of PCWorld.
Hi, everyone.
And we are here with three people from Intel that I want to have go around and introduce themselves. First up is one Robert Hallock. Robert, for people who might not know you, what is your role on Intel?
I lead the enthusiast DIY team, largely for desktop, but a little bit of notebook.
Okay, nice. And then next we have Erin. Erin, this is the first time having a chance to chat with you. Please tell the fine folks at home what you do over at Intel.
Yeah, I am on the enthusiast client side of the house, and I do technical marketing. Okay,
nice. And last but certainly not least is Mike. He's hanging out in a nice little treehouse. And what do you do at Intel, Mike?
So I'm a fellow at Intel. I'm in charge of client CPU performance. I'm also the technical lead of the binary optimization tool.
Okay, awesome. And that's what we're gathered here today, is to talk specifically about the binary optimization tool, how it relates to APO and things like that. The reviews for Arrow Lake Refresh have already been posted. You can go look at our coverage over at PCWorld. We're not going to get into the actual hardware side of it, but I think there is deeper understanding and questions for the software side of it for sure, because IBOT is brand new, and I want to get into it. But before we get to IBOT, there is something else that's new, and it's the IPPP, so the Intel Platform Package. I'm sorry, I don't remember the
Platform Performance Package. It's all good. Package. Brains are a mouthful. They always are.
Yeah. So what is the Intel Platform Performance Package?
Yeah, at kind of a high level. Actually, to take one step back, we have done a lot of soul searching at Intel about what we want to do for desktop performance. And coming off the back of our last gen product, we realized that tidying up the software experience, making it a lot easier for people, was something that needed to occur. There's lots of software bits and bobs now that kind of dictate CPU performance, and even baseline stuff like, are you using the right cores? Are we putting the right cores to sleep? That kind of stuff. Largely software driven. And so if you have to rely on those things, you better make it easy for people to get them. And so we've packaged up everything that's required for performance, power attainment in a single downloadable thing that'll just live on Intel.com, kind of like a GPU driver.
Okay, and is this replacing anything else specific, or where were people getting these pieces of software to begin with?
Erin, go ahead on that one. It's quite a journey.
Yes. So originally, with the original launch that we had with the 200S series, you had to go quite a few different places, whether it's the Intel Download Center, whether it is your motherboard manufacturer site. For the APO UI, you had to go to the Microsoft Windows Store as well. So we're consolidating all of those bits and pieces into one easy package as well. So we're just streamlining it and making it a lot easier to find the software for the performance that you need.
Would we consider this to sort of be the NVIDIA GeForce experience, but an Intel perspective, or the NVIDIA app? I mean, is this the Intel app that we need if you're a PC enthusiast?
Honestly, it's kind of like a GPU driver, right? What we call a GPU driver is actually an HDMI driver, an audio driver, and a graphics driver, and. So we're kind of taking the same idea from a CPU perspective. There's lots of support modules, frameworks, blah, blah, that you need. So just wrap it all up.
And will those things still be delivered in the previous form, and this just makes it a one-stop easy shop, or is this the only way to get things like APO and IBOT in the future?
Here and forward, just the one-stop shop. For this generation product and everything we do on desktop going forward, you just need this.
Okay, all right. Then let's get into the meat of it. For the 200S launch originally, you introduced APO, the Application Platform Optimization. Is that the right acronym?
Go ahead, Erin.
Yeah, the Application Performance Optimization, yes. Okay. It's a mouthful too as well. We love optimization in all of our branding.
And so that one had a specific list of games that were supported that helped to increase performance specifically on the 200S series. Remind people, how did that work?
Yeah, so we have whitelisted games ready for our APO to optimize for each individual platform. APO takes a look at, it's very based on configuration of your PC. What CPU are you running? What GPU are you running? And with that, it works on the runtime optimizations for gaming, making sure there's no such weird things as overthreading happening. It's organizing that game to run a little bit better on your CPU. And currently, I believe with the 200S Plus CPU, we have about 21 APO game titles ready at launch.
And were these optimizations that Intel was doing with the developers, or Intel alone, or could developers actually do some of these?
These are all Intel engineering based. We take a look at the most popular games that are out there, and we take a look how they perform on our CPU. And then from there, we make the decisions what games could use a little extra help when it comes to performance, and that's where APO can step in.
That's right.
And have you felt that APO has been a success for Intel?
I mean, overall, I would say yes. Depending on your configuration, looking at performance, it's anywhere between 5 to 10% extra performance you can get on those select game titles. Which, I mean, when it comes to gaming and you want the highest frames, that's major steps up that you can get when it comes to performance.
To take a slightly different perspective, if I may, like I think the benefit is real and something that needs to be done, right? Because there are all sorts of games that don't always make the right choices when they encounter a CPU that is beyond their understanding, and that happens pretty frequently. Where the whole thing was somewhat frail, though, is in terms of acquiring the right software to turn this on and getting it running. Intel had clear obstacles there that needed to be solved that the platform performance package will solve, because it tidily binds them all together for you. That part definitely needed some work. And so I would wager that most Intel gaming customers, or at least a large chunk of them, have probably not actually used this because of the challenges of installing it. And we hope that making it a little easier will lead to more people seeing the benefits that Erin is talking about.
Robert, if you don't mind me jumping in and asking a question, I'm familiar with what you guys have done from a silicon space for a number of years now. Software is a little bit more of a mystery, and it might be for a little bit some of our readers too. Would you mind sort of explaining where the sort of just how you got to IBOT, just what the history has been in terms of what you have tried to accomplish on the software side? I know you talked a little bit about that sort of privately with the reviewers and so forth, but I think it's probably a good idea to sort of explain this to the readers and viewers as well.
Sure. I'll get into sort of the motivation, but I'll leave it to Mike to do the technical stuff. It's his baby. At a high level, game developers and game publishers are under a lot of time pressure to deliver a shipping game. And oftentimes that means they have either limited QA time to test multiple families of CPUs, older families of CPUs, or they might simply be limited on funding to purchase that kind of validation hardware. And so what game developers are forced to do is sort of consolidate on one to a few CPU families that are incredibly common, and that may not be the latest and greatest. It may not be, right? Because they're trying to target a wide chunk of people for the time that they have. And so that leaves cases where either for reasons of porting or time or finances, they cannot optimize as much as they would want to. And that's a tough choice for them. It really is. But it creates this scenario where there is opportunity out there to recover performance. And even more broadly, if we think about what contributes performance to games in our industry, a lot of the most capable levers before binary optimization might take 5 to 10 years to truly reach the mainstream and become widely available. And I'm talking CPU instructions, processor scheduler changes in the operating system. These things take a lot of time. And so we're trying to think about how can we go faster on newer hardware, and how can we help save the developer a little bit of time that they may not even be able to afford in the first place.
But these developers do their own performance analysis too. What makes why should they use yours? What's the advantage here?
Well, it can happen in two layers. The ideal outcome, of course, is that this is all done directly in source code, right from the author of the project. Problem being that those are very intensive efforts and they take years to realize. And although the performance gains are pretty fantastic beyond what binary optimization can do, it's limited in terms of scale. There's only so many microarchitecture aware engineers to go around. And so that functionally limits the amount of performance you can do in source code. Whereas with automated tooling and some of the systems we set up for binary optimization, we can go a lot wider, a lot faster. And that doesn't necessarily mean it fully replaces the benefit of source code, but it gets pretty close at lower cost and wider scale. And that performance would otherwise be unavailable to users.
One more question, and I'll hand it back to you, Adam. So, I mean, again, we've talked. I mean, you know, if you followed Intel over time, I mean, you know that from a silicon generation to a silicon generation, you're getting 8, 10, 15% performance improvements gen over gen in terms of IPC and so forth. Compare that to what you can achieve in software. Obviously, software is a lot cheaper to write than it is for silicon development and masking and so forth. But have you guys seen that you can improve performance, via software at about the same rate that you do in silicon, more or less? Compare, contrast, if you would, please.
I think Mike has a lot of insight on this one. Go ahead, Mike.
Yeah.
So let me touch upon your last question just briefly. So the gamers tend to do a lot of algorithmic changes, and that's what the software. We've helped them out with that in the past, right? But that's often where they stop. I think Rob had it right on when he said they kind of stop at the microarchitecture changes often. Right. And some go a step further, like you look at things like the Unreal Engine, they certainly do. But a lot of gamers stop there just because there's so much that they need to support out there. OK. And it's difficult for them today. So we are not changing the algorithms at all with IBOT. We're not touching the algorithm. But the microarchitectural optimization, that last bit, let me provide an example here. So we launched a technology called hardware profile guided optimizations. And we did it in Intel's compiler in 2024. We upstreamed up into the LLVM compiler as well, into C-Line. And it on a typical game, what we've seen is it will deliver about 15 to even 25% performance gain if the developer incorporates it in, okay? But a lot of developers don't have the opportunity to. And the collection on it, because it uses our hardware performance monitoring unit, it's very small. It's about 1% overhead to accomplish that, okay? So this is a optimization. We know it's fairly safe. We rarely find bugs in it. In the absence of providing profiling information, the compiler actually makes up profiling information for you. So if it sees a loop, it doesn't know the trip count, it'll assume a 10 trip count on that loop, just as an example, right? And so by providing it profiling information, you get a safe, secure optimization that applies to almost all games out there. But the usage is pretty limited. We do have some games that are using it today, but it's fairly limited. With something like IBOT, we can put it out there and we can even apply to old games that we can impact and make sure that it is performing best on our microarchitecture, providing the best experience for our customers.
Okay, then let's dig into IBOT even more then. And if you can start off by explaining what the difference is between APO and IBOT, and is IBOT a subset of APO?
Erin, go ahead, take the APO one.
Yeah. So APO and IBOT, they work at two different levels. So APO, we say, works more at the OS level, while IBOT works more at the machine code level. So they're kind of attacking optimization and performance from two different ways. With APO, it's looking at things like thread scheduling, core selection, priority execution policies on that side. There's no code changes, doesn't touch anything code-wise on that end. Then we take a look at Intel binary optimization tool. Like I said, that's more at the machine code level. And that's really acting on code layout, inlining, branching, memory behavior that is out there. And that's really taking a look at that compiler flow and that profiling flow that's out there as well. So IBOT kind of lives in the APO UI to turn on and enable, but they're attacking game performance and other application performance just ever at two different levels.
So I think the analogy that you guys used in some of your briefings was sort of like, okay, today, if you have an ARM application running on Windows, there is a translator. There is a way to basically take that code and translate it into a format that ARM processor understands. With this, my understanding is that this is almost an x86 to x86 translator or optimizer. You're taking sort of generic x86 code and optimizing it specifically for your architecture. Can you? That's a little bit. That's something I haven't heard before. Can you explain that a little bit more? How that works,
Yeah.
and where you get the performance increases from?
Go ahead, Mike.
Yeah. So today, what Intel binary optimization tool is doing is it's grabbing profiles from the games, and those profiles use our hardware performance monitoring unit. It's using something called last branch records that tell the path of execution. We also have some events that we're collecting. Think of that as like branch mispredicts and where they're occurring, right? And it's taking a look at that profile and it's creating the best code gen for the machine that it is executing upon, right? That game is currently executing.
Okay. So it knows it knows specifically the configuration of the target machine, your PC.
It certainly does. Now, the hardware profile guided optimizations is an age-old optimization. It's been around since around 2010 using these performance monitoring unit. Even going back further than that, people used to use instrumented profile guided optimizations where you can get as much as a 3x overhead in executing. And you can imagine what that does to a game. It changes the entire way the game executes, right? But with this, we can take production binaries. We take the hardware performance monitoring unit for less than 1% overhead, collecting that. We figure out the paths of execution, any microarchitecture issues that are happening on the system, and we we fix them with the binary optimization.
And so, like you mentioned earlier, Erin, IBOT lives within the APO software. Do you have to have both at the same time? Can a game be optimized with IBOT and not APO, or does it have to have both?
There are games that are just APO only, and there are games that are both APO and IBOT optimized as well. And if you go through the APO UI, so to turn IBOT on, just go through the APO UI. You have to enable advanced mode, and then you will see the nice drop down and toggles of all the games that are IBOT optimized. And you can go in there and turn them on for every single game. You can toggle them off and on, and same goes for APO. So if you want to play around and customize with your system, you have the ability to do that with IBOT.
Yeah. So, I just want to augment what Erin said with a quick teaser here. You can think of APO as optimizing the hardware in the system for the software that's executing. And IBOT is optimizing the software for the hardware that it's executing on. So you're really hitting it from both sides. One thing that we didn't anticipate when we started this is that area in between. There's this fuzzy area that's overlap where you can optimize the hardware and the software both in parallel. And that'll give you a hint at where we're going with this software stack. It is large potential performance gains in that area in between.
Huh. I mean, I've seen the numbers that you've given. I've run some of my own numbers. There is benefit to be had from turning IBOT on for sure. Then I guess I would ask, why is it opt-in only?
Ooh, that's just like that's a philosophical decision that we made. There have been lots of optimizations that have come out in the industry, and I think on the GPU side, everybody is comfortable or unwittingly but okay with the idea of shader replacement, right? There is a graphic shader generically written, may not be optimal for Radeon or GeForce or Arc. and you use your graphics driver to substitute that shader with one that is more appropriate for your microarchitectural specific. We're doing the same thing on a CPU, but that's never been done on a processor before. And so anytime you create a something that is very different from what people are familiar with or accustomed to, you have the potential for concern, upset, and we don't want to entertain that kind of reception. We want to be methodical. We want to be conservative here, so people have time to acclimate to this idea and get used to the technology. Certainly, we would like to turn it on by default, but that felt like a jump too far when you are doing something so radically different from what people are accustomed to. It felt right, and again, philosophical decision, it felt right to make this opt-in until people are comfortable. And we are very much looking at the feedback coming out of reviews like yours and the community at large to decide our next steps on this technology.
Can IBOT be applied to graphics, or is it strictly CPU specific?
CPU specific.
Okay, and the list at launch here, correct me if I'm wrong, is 12 games. How did you pick those games? Because they oddly look like a bunch of stuff that's in benchmarking runs.
It's a combination. The first great filter is this an online game or not? Because currently we do not start online games. We are working on that. We have an entire parallel project going to make sure that goes well for everyone involved, with the express permission of the developer and publisher. So that's big filter number one. Big filter number two, is it relevant? Like, are people using this in reviews? Are they playing it? Is it popular on Twitch? Is it popular on Steam? That's a big one. And then the next big filter is, can you squeeze anything out of this game in the first place? Is there even an optimization to apply? And even in our own performance data distribution, you can see some games get a little and some games get a lot from this. So it's just working that filter until you have a pile of games that can receive a benefit, and then kind of down to popularity from there.
Does IBOT run on any other architecture, CPU architecture? Besides the Core Ultra 200 HX, can you take it back to 13th gen, 14th gen Core, or is this something that's sort of new and going to be added into Intel's processors going forward?
It's the Arrow Lake refresh generation, very specifically, both mobile, desktop, and then anything going forward. Also, it's on Panther Lake right now, the Series 300. But the thing to look for is the graphics device in that system likely to be GPU bound or not? And so if you look at the Panther Lake 12xe product, very fast integrated graphics, fastest ever, but it's still a relatively small graphics device, so it can be GPU bound more often than not. And so in that case, there's not a lot of optimization sort of headroom in the system left over for binary optimization to do anything in the first place. But Panther Lake 4xe, tiny graphics, designed to be paired with the discrete card, that's a great case for binary optimization. Desktop PCs, big graphics card, great choice for binary optimization. So that's kind of another big filter for us of what we want to apply it to, but it's refresh, Arrow Lake, and forward.
Okay, and so I guess if you can help me with something real quick, because if I was an end user and I looked at this list of games that are optimized for IBOT, this could maybe make me think that, oh, okay, well, the game that I like to play is not on this list, therefore it means it's not optimized. How do you describe that to somebody that, like you said earlier, like it doesn't necessarily mean it's not optimized, it just means that maybe we tried and there's not much to get out of it?
The way I would put it is almost every game is optimized enough, right? As Mike alluded to, many of these games are not making microarchitecture specific optimizations. They are performant, they run well. We all play these games. There's thousands of them, but many of them do have 5, 10, 20% performance trapped behind the truth that it wasn't microarchitecturally optimized. And now Intel is the only player that has a tool that can detect those cases and recover it for a user and deliver it as a profile for them. We're very delighted by that capability because it's going to get better and better and better and more sophisticated throughout its roadmap. But the reality is all games are pretty well optimized for PC, but there could be more. There's a higher level there that we can all aspire to, and now we're able to recover that performance.
And what about productivity applications?
Ooh, we have dabbled in our reviewer's guide for the 200S Plus, for example. We did disclose a proof of concept that we're doing for Geekbench 6.5 and higher. Erin, keep me right, 6.5?
6.3 and higher.
3, thank you.
Yeah.
And what you'll find, we're taking the same sets of modules that we use for these games, and instead applying it to some of the workloads that get tested in the Geekbench suite. And some of those workloads get 20 to 30% faster as well. And I want to be clear, like none of those gains actually apply to like the off-the-shelf compiler equivalent of what Geekbench is testing, but it demonstrates that there is potential here.
Yeah,
and
I mean, like Photoshop,
we absolutely
for example.
want to explore that.
Multi-threaded applications, there's a lot of them out there.
That's right.
Nice. I have a little bit of a left field question here, but I got to ask. It's great that this is available on Windows, but what about Linux users? Any chance that they're going to get some optimization as well?
What do you think, Mike?
So we are definitely looking at Linux. A lot of the folks I had several pings this morning and give me an ETA. When are you going to be available on Linux? We're not ready to announce when we're going to be there, but we are definitely working on it as we speak.
Mm-hmm.
Will it also be a GUI-based application like it is on Windows, or is that something that could be optimized and pushed to the driver level? I'm sorry, the kernel level.
So
I think it's our call. Yeah, we'll just leave it at that.
Okay.
I think we all know you can do terminal UI and you can do GUI, and it's a choice. We're not ready to disclose which one we want to do.
Okay, nice.
Now, it sounds like you have a roadmap in place for IBOT as well as IP3 or Intel Platform Performance Package, whatever you want to call it. Can you talk a little bit about that?
I'll do the IPPP piece, and Mike maybe tackle the IBOT piece. Some things I'd love to add to our platform performance package in the fullness of time. Automatic updates is a great one, right? If we're issuing profiles for users, could be really nice if it was automated. I think some of these user interfaces are probably getting a little long in the tooth at this point. They've been around a while. User interface design methodology has changed, so maybe updating the UI a little bit. Future platform features, which of course I can't go into, are a prime candidate for this package. But now we at least have a vehicle to deliver these sorts of capabilities. But that's a taste of what we're thinking about.
Okay, and can you give us a hint on the cadence of games that will get, or other applications that will get supported in the future?
Kind of as needed. Like, we're not on a monthly schedule or a quarterly schedule. It is not rigid. When we find something new and interesting, we're just going to package it up and send it out the door. And that is also the advantage of having this new distribution model. Intel was not set up to issue updates like that in even a year ago.
And I would just augment what Robert said, and you guys have asked about several times, scaling is something we're very interested in. And two types of scaling, like one, we would like to bring that improved experience to more users and more software, right? And so that's very much on our mind. We want to scale, but we don't want to cause anyone harm, in putting out the software too quickly. And so we're being a little bit hesitant about that. And scaling, how do we scale software? How do we make sure we maintain the great experience across platforms on that? So that's a big one that we're working on right now. A second one is scaling optimizations, right? And so we have not applied all of the optimizations we can. In fact, we've been fairly conservative about this technology. We have not started to flex yet. And so scaling those optimizations, so we've got these larger gainers, so they're scaled across applications and types of applications, is something that we're working on right now. And how do we bring it to other operating systems like Linux, right? How do we do that? Make sure that they're enjoying the experience as well.
Okay. I guess my last question, I don't know if Mark has another one, but with the if you buy a Team Red CPU and an X3D, you don't have to worry about downloading some sort of software to get the benefit of that extra 3D V-cache. With this, you are asking somebody to go out and, number one, know that it is a piece of software that they even could get. Number two, then they have to download it and install it. So it's a little bit more of an ask. I mean, depending on, for me, it's easy, but for others, they might not even know it exists. Is there a potential future where they wouldn't even need to think about this? They get a new Intel CPU, they put it in, and they're just able to benefit from it and not have to worry about thinking of it.
Certainly. We are watching this feedback very, very closely. And what people say about this technology, their overall tone and tenor in the room about how the market and the industry is receiving this absolutely influences our future decisions on, default off, where do we want to take this? And can't say yet because we're still reading all the reviews and gathering all the feedback and letting it percolate for a while. But yeah, it is the dream to have all of this stuff default on if people seem comfortable with that. But at the same time, every vendor now has some piece of software that you must explicitly know about and opt into. And we all call it different things, and they're all critical for performance. So the bottom line that I would deliver to anyone on any gaming platform, I don't care if it's an Intel or otherwise, get your platform drivers. You need it, right? For peak performance, you must have it. And I don't care what gaming CPU you have. So that's my takeaway.
Okay, nice. Is there anything else you want people to know about APO, IBOT, IPP that we haven't covered here yet?
I've talked enough. Mike, do you have any final thoughts for folks?
For me, I'm very curious about getting the customers involved, getting the gamers involved. Do you like it? What do you want us to focus on? Do you want us to focus on slow frames? We can do that, right? Do you want us to focus on just boosting the average FPS? Did you have a positive experience? Did you have a negative experience, right? And then for the developers, we're going to be giving a path for them to also be included in this experience. And so I'm very curious about getting their feedback here and, what works for them, what doesn't work for them. That's where our head is at currently.
How would users actually provide that feedback?
We're watching.
All the time.
But that's the honest truth. We, because of this new enthusiast team that we have, we are all ourselves gamers and PC enthusiasts. And whether you know it or not, we are lurking on Reddit. We're on Blue Sky. We're on the artist formerly known as Twitter. We care very much about what people are saying in this industry. And we are constantly trying to coalesce a sort of the through line opinion that unites all this feedback. It's going to be mixed, of course, but there's probably some emergent crowd wisdom coming out of this. And yeah, we watch for that. We care about it.
I will say that, with all the skyrocketing prices, with all the shortages and so forth, just the fact that we are able to get some sort of performance boost without having to open our wallets.
Mm-hmm.
I think that on some level that's appreciated, so I will say that. Yeah.
Yeah. And
How about you,
definitely
Erin? Final thoughts?
Oh, sorry.
Yeah, no, I'm looking forward to, seeing the feedback in there. And Mike himself said his team haven't begun yet to flex. So let's see what they have. So yes, please give us all the feedback on there. And I can't wait to see, what the next rendition of IBOT can look like.
Okay, then I appreciate all of you taking the time to join us. And yeah, if you have feedback, maybe you can get them in the Full Nerd Discord, link down in the description, and we'll catch you on the next episode. So thank you, Mike, Rob, and Erin, and thank you, Mark, and we'll catch everyone later. Bye.